Good morning all. Here's the power board out of Fuji Electric Frenic 5000G11. Now we have some damaged firing channels over here, and we're going to take our meter and go through and find the damaged parts. Now some of the parts are obviously damaged. Like I can see this resistor is burnt. This one is cracked open. It looks like we have some problems over here with this firing channel. I can see a resistor with a hole in it. The parts up here, here's two transistors. They're cracked open right there, so they're going to have to be replaced. And I'm not sure about these diodes. We're going to have to check those. So let's put our meter into diode test mode. Turn the light on here. Can you all see that? There you go. Let's check this diode right here. It's labeled ZD4. Okay, that diode is shorted. Let's check this other one over here in this firing channel with the resistor with a hole in it. That one's shorted. So, I'm going to have to order some parts. I'm going to replace, of course, these two transistors, this optocoupler, the bad resistors. I'm going to change all of the capacitors in these firing channels, but it looks like just the two firing channels were damaged. Let's go ahead and sample another diode here to see what it looks like. Okay, there's a Zener diode, and it has a diode drop of 0.673. Let's check these diodes up here. Yeah, that one's got a problem too. How about this one in the other bad firing channel? That one appears to be okay. Let's look at this one over here in the good firing channel. Okay, that's a different diode drop. 0.463 compared to 0.4. So, and the resistors, let's check the resistors. We know they're bad, but let's go ahead. Here's a good one. It measures 4.9 ohms. Let's check the one that's burnt. It's open. Here's a good one. There's 10.3 ohms. Let's check this one that's cracked open. Yeah, that one's open. So it looks like everything in this firing channel is going to get replaced, and everything in this firing channel is going to get replaced. Well, here's our problem. This Zener diode has no markings on it. It is shorted, but what value Zener is that shorted Zener diode? Where does it Zener at? What is the voltage? So in this case, what we have to do is pull a good Zener diode from the board and set it up so we can test it, so we can see what the Zener voltage is. And that way we'll be able to replace the two shorted ones. Okay, let me remove a good Zener diode and test it. There's the Zener diode, the good Zener diode that we're going to remove. There we go. that does. Okay, it's loose. There's our Zener. Set our meter to volt mode. There's the ground side of our power supply. Let's make sure that's turned down. Here's the positive side. Positive side. I get that turned over here so it don't get in the way of our meter leads. It's going to go to our 1 kilo ohm resistor. The ground side is going to go to the anode of the Zener diode. Now we're going to join the other side of the 1 kilo ohm resistor to the cathode of the Zener diode. We're going to take our meter lead connect the red lead of our meter to the resistor and cathode, and we're going to connect our black lead of the meter to ground on the anode side. So here we go. Okay, the voltage is increasing on the meter. We're still moving. Okay, I have about 20 volts across the resistor and anode side, and we've stopped at 15.81 volts. So that Zener, we're looking across the Zener. This is the voltage across the Zener, and it is 15.81. So the actual value of that Zener diode is 15.81. And Zeners are rated at 15 volts or 16 volts. So I would say this is a 16 volt Zener. There you go. That's how you test a Zener diode. Now we know what to put in the place of those two shorted Zener diodes in those two bad firing channels. Alright all, we got some parts to order. Hope you're having a good day. And we'll see you next time.